Today I'd like to talk about how to interact with nodes using Houdini inside Python. So to do that, let's come over to the network editor here, Control B to go full screen. I'm going to create a geometry node, and we're going to look at the 5 platonic solids. So we're going to go ahead and create a geometry container, call it platonic solids. Double click to dive inside that node. And now let's actually put down all the platonic solids. So there's a platonic solid node. Drop that down. And over here, there's the 5 types of platonic solids. And for whatever reason, they include a soccer ball and a teapot. But those are not platonic solids. They're fun test geometries. I don't know why they're included here, but what can you do? So the first one we'll look at is the tetrahedron. Let's leave full screen, and you can see the tetrahedron is there. So I'm in the technical desktop. Let's give ourselves a little bit more room so we can see where the action is. We don't need the Python shell right now. We will in a minute. And we don't need the tree view right now. So let's just stick with this. Come over here, we can see that we've now created one shape, one of the 5 platonic solids, the tetrahedron. I'm going to take and reposition this using the ladder tool, as it's called. Okay, now up in the network view, let me zoom out a little using my mouse, and let's lay down another platonic solid. Once again, there's 5 that we're after, so let's make this one the cube. Okay, now you can't see it because inside a geometry node, only one of the nodes can be visible at a time. So how can we see both of them? We can see both of them by putting a merge node down. And we're just going to merge these two, and we're going to click the display flag on merge. Now we can see both the tetrahedron and the cube. So let's select the cube and let's move that. Whoops, I did not mean to resize it. Let's move it in the Z direction. By the way, one thing I really like is down here in the lower left corner of the viewport, you can see the orientation. And a nice mnemonic is RGB is XYZ. Let's go ahead and finish this off. So I'm going to hide this for now, and we're going to go full screen and do this quickly. Okay, we're going to make another platonic solid. If you hold down Alt and drag, it'll make a copy. That speeds things up a bit. So this one, we're going to make the octahedron. This solid, we're going to make the icosahedron. And lastly, this solid will be the dodecahedron. And we're going to select all 3 of these at once. And then by dragging down to the merge, we can merge them all together. So that's a little shortcut when in the network editor. You don't have to do things one at a time. You can do them in bulk. I'm just going to rearrange this to make it a little nicer. One keyboard shortcut, if you come up here and look at the tools, let's see, where is it? Okay, if you look at the select layout, layout all is L. If you select L, it will just kind of rearrange all your nodes into a nice configuration. Let's just call it combined shapes. So Control B, hit H over here to just kind of rezoom and center it. And let's bring back the parameter pane. You can see right now we have 3 shapes on top of each other. So let's move the icosahedron. We're going to move it in the X direction using the ladder tools over there. And we might even resize it a little bit. Just give ourselves a little more room to work with. And then the dodecahedron, we're going to bring that forward a little bit and resize that as well. And let's just zoom out, and there we go. We have 5 platonic solids, all inside a geometry node. Now let's use some Python to grab these things and inspect them. So if we expand the tree view, you can see inside the object folder, if you will, the object context. Actually, it's not the context. What's it called? If we go up here to the root, you can see all kind of like the top level folders. And if you click on one and select I, you can see it's called the driver manager. So for rendering, the driver manager. For geometries, we're using the object manager. So they're actually called managers. I always forget that. So we're going to go to the object manager. Inside we have a geometry node called platonic solids. Inside that we have the 5 shapes, and they're combined using a merge node that we called combined shapes. Now it's time to return to our Python shell. The first thing I want to do is grab one of these nodes. Let's grab the geometry node called platonic solids. The way to grab a node in Python is type in HOU, that's the Houdini module, and hit dot. You get this pop-up with all the things you can do, and it's a lot of things. Keep in mind the Houdini module is essentially going to give you access to anything you see up here. Also, if you come over to the network editor and click tab, you can see there's a lot of things, a lot of nodes you can make. And the module has to have that. That's so when you hit dot and you get this pop-up, don't be overwhelmed. Essentially, this is going to give you access to anything you need. What we want is a node. So we're going to type in N for node, and this is what we're after right here. There's a little F next to it, meaning it's a function. So let's just double click it, do open parentheses, and it lets you know, given a path, it will give you that node. So we need to put the path in quotes because it's a string. And let's just start with /. And this is going to give you a nice pop-up to auto-complete the path. We are working with shapes or objects, so let's double-click that. And we want the platonic solids one. Now, inside the platonic solids shape are lots of other children. There's 6 child nodes, but we're not going to worry about that right now. Let's hit quotes, in parentheses, and there we go. So we grabbed the node, but we didn't give the node a name, so we can't actually do anything with it. So let's hit the up arrow, it'll return us to that. And let's call this our geo node. Actually, let's do something a little more interesting. Let's call it shapes. Enter. Now if you type in shapes and hit enter, it returns this little bracket thing, which lets you know what type of node is it. It's an object node. It's more specifically, it's a geo node, and then it gives you the path. Let's do Control B and go full screen. So with shapes, if you type in the name shapes and hit dot, there's a lot of information about this you can access. One is you can access, let's scroll down a little bit, there we go, path. Now you see that path has an M, that means it's a method. A method is like a function attached to an object. So that means you need to type in parentheses for it to execute and hit enter. And there is the path to this geonode. Notice it's the same path that we see up here. So if you just type in shapes, you can see it displays the path here, and calling the method path will also give it to you. You can also get the name of it. You can type in name, parentheses because it's a method, platonic solids. And you can also look at the type. Now if you type in type, you might expect it to output object node or maybe geo. But type is an object because it contains a lot of information. It contains specifically what kind of node it is, what name it is. I mean, a lot of information about it. That's why it just doesn't pick one thing. So we might be interested in, well, for the type, what is the name? Sorry about that. What is the name of the type? It's geo. And we can see that up here. So those are 3 interesting things you can access. You can access the path of your node, the name that you gave the node, and then also, if you want the name of the type, you have to first get the type by calling the type method, then you have to call the name method, and it'll let you know what that is. Now, nodes in Houdini can have parents and children, actually one parent or a lot of children. It also can have inputs and outputs. Let's leave full screen. So if we go back to the network view, this node has no inputs and it has no outputs. So if we come over here and type in shapes and type in inputs, it returns nothing. And that's not a surprise because this node has nothing inputting into it. Well, what about outputs? Once again, nothing. It doesn't. It's an empty list because nothing's coming out of it. Now, if we double click this node, inside there's 6 nodes, 5 shapes and a merge. We call those child nodes. So if you take the shapes node and say, what are the children? Let's go full screen and do this again. And it returns a list of all the child nodes in here. We can see there's the tetrahedron. cube, the combine shapes node. So this is the merge node. You can see here it's a SOP node of type merge, and it gives the path. SOP node is like a surface operator. It means it's a geometry node. Then there's the octahedron, icosahedron, and dodecahedron. Notice this just gives you the children. It doesn't let you know how they're connected to each other. It just says these are the child nodes. Okay, let's leave full screen. If we double click on the platonic solids node, let's minimize this. We might want to inspect the tetrahedron. So how do we get that? How do we grab that node? Using the Houdini module, we're going to type in node, and it wants the path. So once again, put the path in quotes because it's a string. Start with a / and just follow the pop-ups. Double click obj for objects. Double click platonic solids. And inside there we have the 6 child nodes. We're interested in the tetrahedron. Interesting thing, notice there's still a pop-up here. We'll talk in another video what is going on here, but this actually now gives you access to the parameters of it. But for now, we're focused on nodes. We're not talking about parameters, so let me hit escape to get rid of that pop-up. Quotes, close parentheses, and there we go. Once again, I forgot to give it a name, so let's hit the up arrow, and let's call this tet, because a lot of people will call tetrahedrons in 3D software, in VFX, they'll call them tets. There we go. We now have a name for it, so if you type in tet, it returns kind of this summary of what the node is. And we can look at the information we saw earlier. So if you type in tet.path, there is the path to this, which is outputted in the kind of like the summary string. Another way to see this is if you come up to the tree view, under the object, I'll call it a folder because it does look like you're browsing folders and files on a computer, even though now you're browsing nodes and parameters. Here inside the object folder is the platonic solids node. Inside that, there are 6 child nodes, and the one we're looking at is the tetrahedron. Notice there's a plus here. If you click on it, there's a lot of things inside of this. And we'll talk about what those things are in a separate video. Once again, it's more that we can now grab a reference to this node using Python. And soon we'll learn how we can actually go in and fiddle with it and change things. So that's the path. There is the name. We called it tetrahedron. If I come over here and just call it tet and look at the name, it's tet. Let's come over here and let's call it something else. How about Michael? So fantastic name. That's my name. There we go. So let's just go back to tetrahedron. Now this one, if you double click this, oh my goodness, look what you see here. So a tetrahedron is actually a container for a big network of nodes. And this is what Houdini gives you out of the box. They don't require you to go through and make all the points, edges, put them together, orient them properly. They give that to you out of the box, so you don't have to do that. So I'm going to hit U to go back up. So let's leave full screen. And on this tet node, let's see, there's no inputs, but there is an output. So let's take a peek. If you look at the inputs, there's nothing. But if you look at the outputs, there is one node that it's outputting to, and it's outputting to the merge node. Now, what about parents and children? The tetrahedron node is contained in the platonic solids node. So let's see, if we call parent, notice it's not plural, it's singular, it's parent. Parentheses. It's contained inside the platonic solids node. And what about children? Actually, there's too many to show here, so I'm going full screen. So we're going to type in children. There we go. There's a lot. And it's a little overwhelming. You might want to say, well, how many are here? There's a Python function called len, which is short for length. And it will return the length of like a list or a sequence. So now let's see, how many children are there contained inside the tet node? There are 34. And you can kind of go through and look at the other platonic solids. If you double click cube, it has its own network, which you can see it's kind of grayed out. They don't want you coming in here and messing with it. You can if you want to. But you can see there's this little lock that shows it's kind of locked. So I'm not sure. I'm going to go cuckoo here. If I click this and hit the delete button, nope, permission denied. And that's because it is locked. You can unlock these, I believe, if you want to go in and do something different. And then the merge, if I double click merge, not going in. So that is interesting. Let's take a quick peek at that before we call it a day. So let's get the merge node. We'll call it merge equals. Once again, we type in HOU, the Houdini module. We're going to get a node, quotes, and start with a /. Under the objects node, there's the platonic solids node, which contains the combined shapes node. Now this node, let's go ahead and look at it and make a few guesses. By double clicking on it, it looks like there's no subnetwork contained inside of that. So it looks like it might have 0 children. It should have 1 parent. If you hit U, the parent should be platonic solids. It looks like it has 5 inputs and no outputs. Let's check to see if that comes out the way we think. So we have this merge node. Let's look at parent. 1 parent, platonic solids. That's what we thought. Now, what about children? None. Okay, that matches what we thought. Now, if we look at inputs, we thought there was 5. It gives us a list. Let's go ahead and type in the length function, the count, and count how many inputs there are. There are 5, and we see there are no outputs. And let's just confirm, are there any outputs? No, there are no outputs. So that is a quick overview of how you can take a geometry with lots of different nodes. These nodes, if you double click on them, will sometimes have subnetworks. And what you can do is grab references to them using Python and interact with them. This is the first step, being able to get a node by its path. And once you have that, with a little bit of Python code, you'll be able to start to do things very quickly and in bulk that might be too slow to do by hand. Okay, thanks for watching.